The second day of properties of exponent notes, we're just going to do a bunch of problems. So problem one, simplify this. So if I'm looking at this, there are a lot of different ways I can do this. I can try and multiply this exponent into all the other exponents because that's one of our properties. And I can also do 5 to the negative second power and 25 to the negative second power. And I'll get the right answer. It's just going to take a lot of work to get there. I would recommend simplifying the inside first and then dealing with the negative 2 power. So 5 divided by 25 is 1 over 5. Let's remember that numbers are still numbers. Exponents are treated a little bit differently than numbers. Now, x to the fifth over x to the third is x squared in the numerator. Because if I wrote out 5x's on top and 3x's on bottom and canceled off how many x's were in common, there would still be 2x's left on top. Y to the negative fourth over y. The way that I like to do this is anytime I see a negative exponent, I'm going to actually relocate it because we learned yesterday that when we have negative exponents, it's the same thing as a positive exponent in a different spot. So if it's a negative exponent in the numerator, it's the same thing as a positive exponent in the denominator, and vice versa. Negative exponent in the denominator, positive exponent in the numerator. So if I'm looking at this, y to the negative fourth, I'm just going to move that to the bottom. So now on the bottom, I have a y and a y to the fourth. That means I have a y to the fifth power on the bottom. Then I have this z to the seventh over z to the negative eighth. I'm going to move this to the numerator. So that is z to the seventh times z to the eighth in the numerator. I have z to the 15th in the numerator. All of that is to the negative second power. Then over here, for the right side, I don't have to simplify the inside at all. So now I'm just going to do the 2/3 power of this. 8 to the 2/3. I can do that in two different ways. I can do 8 squared first and get 64. And then I have 64 to the 1/3 power. And that's like the cubed root of 64, which is 4. I can definitely do that. So I would get 4. But understanding that that's not going to be the best way to go about it if, let's say, I have 8 to the 5/3, because then I would have to do 8 to the 5th, which I don't really know off the top of my head, and then do that to the 1/3 power. It's a whole lot easier if instead of doing the numerator of this first, I do the denominator first. So I do the 1/3 power of 8 first. Well, the 1/3 power of 8 is 2, and 2 squared is 4. Well, that is way easier. I got the same answer, but I dealt with way smaller numbers. So that's kind of how I'm going to go about this. And that would work even if I had 8 to the 5/3 power. So in this hypothetical problem, 8 to the 5/3 power, if I do the cubed root of 8, I get 2, and 2 to the 5th is 32. Well, that answer is way easier to come by if I do the denominator of this first. So 8 to the 2/3 is 4. X to the 9th to the 2/3, I can just multiply 9 and 2/3 because that's power to a power, and I get x to the 6th. And then y to the 6th to the 2/3, I multiply those and I get y to the 4th. Now, last thing I'm going to have to do before I do the final simplification is I need to square everything that's on the inside of this parentheses and flip it from the top to the bottom or the bottom to the top. That's what a negative exponent does. It moves things basically to the opposite side of the division bar. So all of these things need to get squared. 5 squared is 25, and y to the 5th squared is y to the 10th. That now becomes the numerator because it's to the negative second power. X squared is x to the 4th, and that's on the bottom. Z to the 15th squared is z to the 30th. Now I could have done that by saying x to the negative 4th, z to the negative 30th, 5 to the negative 2, y to the negative 10, and then flipped everything. But it was just kind of easier to do it all in one step. And then I multiply that by 4, x to the sixth, y to the fourth. So the final answer, after I simplify everything, is going to be 25 times 4 is 100. Y to the 14th is going to be in the numerator. And an x squared is going to be in the numerator because x to the sixth divided by x to the fourth becomes x squared. So I have x squared y to the 14th over z to the 30th. And that's my final answer for number 1. Number 2, I'm going to rewrite this as x to the 36th, y to the 17th, over a to the 12th, b to the 15th, to the 1/3, to the 1/4. So now when I do that, I have all this power to a power stuff going on. Now when I do all this power to a power stuff, 1/3 times 1/4 becomes 1/12. So x to the 36, y to the 17, over a to the 12, b to the 15, to the 1/12. And then now I can just multiply all of the exponents. So as I multiply all the exponents, x to the 36 to the 1/12 is 36 divided by 12. X to the third, y to the 17 over 12 is just y to the 17 twelfths. A 12, 1/12, so that's just a. And then b to the 15 twelfths, well, I can reduce 15 twelfths. That's 5 over 4. So that is the answer to number 2. Number 3, simplify and rewrite in radical form. Oh yeah, well, the directions to this were rewrite in exponential form, and I kind of just did it without talking to you about it. But now simplify and rewrite this in radical form. So if I'm going to rewrite it in radical form, actually I'll simplify it first. So 27 to the 2/3. Remember we talked about the best way to do this is to do the 1/3 power first. So 27 to the 1/3 and then square that. So 27 to the 1/3 is 3, and then 3 squared is 9. So I get 9, and then 21, or x to the 21 to the 2/3, that becomes x to the 42 thirds, which 42 is divisible by 3, that's 14. So x to the 14th power. Then y to the 5, and then to the 2/3 becomes y to the 10 thirds. So this is the only thing that actually can be moved into a radical. So the 9 stays on the outside, the x to the 14th stays on the outside, and then y to the 10 thirds, I have y times y times y times y to the 1/3, because all of these are y to the 3/3. That's basically what's happening. So I have y cubed on the outside, and then I have a cubed root of y. And then that is rewriting it in radical form. There's only one thing that can be on the inside of a radical there. Number 4, the easiest way to go about doing a problem like this is to get everything in terms of the same base. So if I see 125 and 25, I'm going to want to rewrite 125 as 5 to the third. And I'm going to want to rewrite 25 as 5 squared. So let's rewrite these. So I have the square root of 5 cubed over the fifth root of 5 squared. And that's not really helping me very much, but if I now rewrite these in exponential form, that can help me a lot. So now I have 5 to the 3/2 divided by 5 to the 2/5. And this is something I can deal with because the bases are the same. So now I can maneuver with the exponents. And I know that this rule is if I have a division problem with the same base and different exponents, I can rewrite it as 5 to the 3/2 minus 2/5. So now I can just manipulate this with subtracting fractions. So let's get a common denominator, 5 to the 15 tenths. And then 2/5 is 4 tenths. So this becomes 5 to the 11 tenths. So that would be my final answer in exponential form. If it wants it to remain in radical form, then I would have to rewrite it as 5 times the 10th root of 5, because I can pull out 1, because I can't write it as 5 to the 11th in the 10th root, because that would be too many 5s to keep on the inside. So that would be in radical form. This would be in exponential form. Finally, I have a similar situation over here. So this is 7 to the 4/5 divided by 7 to the 11/6. So I'm going to rewrite this as 7 to the 4/5 minus 11/6. Let's get a common denominator. The common denominator is 30. So that's 7 to the 6, 12, 18, 24 over 30 minus, I'm going to multiply this by 5 in the numerator and denominator. So that's 55 over 30. So this is 7 to the negative 31/30ths. So if I were rewriting this in exponential form, I have a negative exponent, which means I rewrite it in the denominator. Um, and then there are a couple different things that we have to do to talk about here. If this is in radical form, and I'm going to erase some of this over on this side just so I can do a little bit of teaching. But if I am dealing with radical form, so let's say I have 7 to the negative 31/30ths, I would rewrite that as 1 over 7 times the 30th root of 7, because the negative exponent moves to the bottom, and then 7 to the 31 to the 30, I would have to pull out a 7. So that's something that I'm pretty aware of. Now, I cannot leave it like this because I have a radical in the denominator. So just like we learned in Unit 6, I'd have to multiply the top and bottom by however many copies of 7 on the inside of the radical I would need in order to make the bottom a nice number. So um, that's not what I'm supposed to write there. So those, I need this to be a 30th root of something, and I need 29 copies of 7 on the inside, because if I have 30 copies of 7 on the inside of a 30th root, that ends up being a regular 7. So the denominator is going to end up being 49, and the numerator is going to end up being the 29th. I did that again. It's going to end up being the 30th root of 7 to the 29. So if I want to write this as a final answer, I would have 49 on the denominator and the 30th root of 7 to the 29. We don't expect you to know what 7 to the 29 is. And then if we were writing this in exponential form, that would be 7 to the 29/30ths over 49. So both of these, the left one's radical form, the right one's exponential form, would be the accurate answer. We can't leave it as either this or this or this, because all of those would have radicals in the denominator, and we have to rationalize the denominator in this problem.